Hi everyone, welcome to the next video. We're going to be looking at U substitution with trig functions. We'd already had the introduction to U substitution. And then also I want to add U substitution with definite integrals. So we're going to use the same process that we did before. We're going to identify U, find du, and then integrate. So on this first one, number 1, cosine 4x dx, we know that U is going to be 4x, du dx is 4, so du is going to be 4 dx. All right, so if we rewrite this, we have cosine 4x dx, and so we know we need a 4 and a 1/4. So if we rewrite this, we have 1/4 cosine u du. The integral of cosine is sine, so we end up with 1/4 sine u. We're going to substitute back, so this will be sine 4x and then plus c. The next one over here, we're going to let u be the part inside the parentheses, so u is 1 minus 3x. So du is going to be negative 3 dx. I skipped a step there. I hope you kind of followed along. Rewrite. I have sine 1 minus 3x, and then I'm going to move the 3 over with the dx. I'm close. I've got everything but the minus sign. So I've got the negative here and the negative 1 out here. If I rewrite this, I have negative 1 sine u, and then this is du. The derivative of sine, or the integral of sine, is negative cosine, so this is going to be cosine u, and u was 1 minus 3x plus c. Example number 3 has sine to the third, that's a 3, sine to the third power x cosine x dx. So remember that we can rewrite that as sine x to the third cosine x dx, right? And since this is the part in parentheses, we're going to let u be sine x. Okay, and so du would be cosine x dx. All right, so we can see here that we have that already. So I'm going to rewrite in terms of u. So I have u to the third du. Well, that's u to the fourth over 4. U is sine x, so sine x to the fourth over 4 plus c. And you, of course, could rewrite it this way, sine to the fourth over 4 plus c. Okay. Now, on the next one, we have the integral of tangent 10x secant 10x dx. We know that the integral of tangent u secant u is secant u. So we know we have that already. So we suspect then that our u is going to be 10x. So u is equal to 10x. du is equal to 10 dx. And I'm going to rewrite this. So I have tangent 10x secant 10x and then dx. So I'm really close. I have that. I have the x, but I don't have the 10. So I'm going to add the 10 and the 1/10. I'm going to rewrite it with a u. So this is tan u secant u du. All of this goes to du. And so I have 1/10 of secant u. Well, u is 10x plus c. So in the next example, we have tangent squared x, secant squared x, and when both of them are squared, it's kind of hard to know which one of them should be u. So let's pick one. Let's let u be secant x. And so when we take the derivative, the derivative of secant x, if you look it up, is something horrible like the natural log of secant x plus tangent x. Well, absolutely fine. There is absolutely no way that we can get that when all we have is a tangent squared and a dx. So this is not it. This is not u. All right, so we're going to try the other one. So we're going to let u be tangent. When we say take the derivative, that's going to be secant squared dx. And if we rewrite this, we can see right away that those two things are the same. And so we know we found our u. So we know that u, this tangent x is u, so we're going to rewrite it as u squared du, which will be u to the third over 3. Now there's a tendency here, isn't there, to just take the derivative or whatever, but just integrate. The integration is just x u to the third over 3. So we're going to substitute then. We're going to substitute for u is tangent x, so we have tangent cubed x over 3 plus c. And that is our final answer for that one. Okay. Now, number 6, we can see that easier that that's under the radicals. So we know that the u on this case is going to be cosine x. And so du is going to be negative sine x dx. If we rewrite this, right, we have cosine x to the 1/2, and then we have sine x dx, and we're really close, right? We've got the sine x dx, but we don't have the negative. Okay, so we're going to rewrite u to the 1/2 du, and that's going to be u to the 3/2 over 2/3. Don't forget the negative, and then rewrite it. Negative 2/3, u is cosine x, I just looked up there real quick, to the 3/2 power plus c. And here's our final example, number 7. You can see here this is a little more complicated, but not too bad. We're going to let the part under the radical be u. So this is 1 minus sine x du. I have more room, I'm going to write bigger. Is going to be negative cosine x dx, cosine x dx, and negative cosine x dx, and then I'm going to rewrite. So I'm going to put the radical 1 minus sine x to the negative 1/2 power, and then cosine x dx. Don't skip this part where you're rearranging and putting them in the right order, because you can get lost in these problems really easily. And if you don't stay organized, and if you don't kind of do them the same way every time, then you really will you'll get lost. All right, so that's my du, so that needs to be negative, and so does that. I'm going to rewrite it, so I'm not even skipping that step. So this will be u to the 1/2, negative 1/2, du, right? And then I'm going to integrate. So I have negative, and then add 1, so this is 1/2, and then 2. So this will be negative 2 u, which is 1 minus sine x, to the 1/2 plus c. So here's another aspect to using U substitution. Remember that we're using U substitution because the derivative that we're integrating or taking the antiderivative of was obtained by using the chain rule. And so what we find here is when we are trying to evaluate a definite integral, remember a definite integral is going to yield an actual number, we're going to need to use U substitution again to evaluate the definite integral. So I want you to look at first at the notation here. It says that u equals g of x has a continuous derivative on the closed interval. F is continuous on the range of g. And so if you look here, do you see this f of g of x times g prime of x? This is a derivative, right? And it's the same thing then as using u for the g of x, right? And so here's the u, and then the integral of g prime, right? G prime is du. But you'll notice too that the integration, the values of integration, the limits of integration, have now changed. G of A and G of B. Notice that G is U. All right, so let's just do an example because I think that'll be the easiest. We're going to evaluate from 0 to 1 x times the x squared plus 1 to the third power dx. All right, so to evaluate it, we're going to let u be x squared plus 1. Boy, that was really wide. Hold on, I'm going to make that a little smaller. And then you're going to obtain that u is equal to this, and so du is equal to 2x dx. All right, so down here, let's get started. We'll have our integration. U is x squared plus 1, so we're going to have u to the third power. I have 2x dx, but I only have one x here, so I would put a 2 here and a 1/2 on the outside. So 1/2, that makes my dx du, right? And so now I just need the limits of integration. And so I'm going to come back here. If I have g of x is my u, right? So that's going to be x squared plus 1. Then I want to put in 1, which is the upper limit. So this would be 1 squared plus 1, which is 2. And so that new limit of integration is going to be 2. And then if I do g of 0, I'm going to get 0 squared plus 1, which is just 1. So I'm going to evaluate the U substitution from 1 to 2. Okay, so I'm going to do, this is going to be 1/2 times u to the 4th over 4 from 1 to 2. And that will get me u to the 4th over 8 from 1 to 2 is going to be 16 over 8 minus 1 over 8, which will get me 15/8. Now, here's the ironic thing. The ironic thing is if I came in here and instead of having u to the 4th over 8, I could substitute u to the 2nd plus 1. So in other words, I could do u to the 2nd plus 1 to the 4th over 8, and I could integrate this from 0 to 1, and I would get the same thing as if I used U substitution with the new limits, upper and lower limits of integration. So this is a different way of thinking about it. I'm going to do a couple more examples. Okay, so here's my definite integral. I know that the part that's u is going to be 2x to the 4th plus 1. That makes du 8x to the 3rd dx. All right, so I have x to the 3rd and dx, so I need an 8 to go with it, and then that would put a 1/8 on the outside. So I have 1/8, my integral. This is u right here, so this will be u to the 2nd. This and this is du, right? And then I need new limits of integration. So I'm going to do g of 1, and that's going to be 2 times 1 to the 4th plus 1, which is 3. So that's a new upper. And then g of 0 is going to be 2 times 0 plus 1, which is 1. And now I'm going to evaluate. So I have 1/8 u to the 3rd over 3 from 1 to 3. Let me tighten it up a little. U to the 3rd over 24, 1 to 3. And that's going to get me 27/24 minus 1 over 24, which is 26 over 24, which is 13/12. So here's one more example using U substitution. So I'm going to let the inside be u equal 1 minus x squared. Du is negative 2x dx. I need a negative 2 here and a negative 1/2 out here to have a form of 1. So as I rewrite, I've got negative 1/2. I have u, the square root of u is u to the 1/2 and my du is satisfied. Okay, I need new upper and lower limits of integration. I'm using the U function, so I will have g of x is 1 minus x squared, and g of 1 is 1 minus 1 squared, which is 0, and g of 0 is 1 minus 0 squared, which is 1. So I'm going from, be careful that you're not, because it basically switches them around, right? So it goes from 1 to 0. So I'm going to integrate. So I have a negative 1/2 times u to the 3/2 times 2/3. The 2's cancel. That will be from 1 to 0. So this is negative u to the 3/2 over 3 from 1 to 0. So I'm going to put the 0 in first. So I've got this equals 0 squared, or 0 to any power, right, over 3, minus, and then I'm going to put the 1 in. So this will be negative 1/3. So a negative times a negative is positive. So this is going to equal 1/3. Okay, so some of this was a review, some of this was not. We are going to practice doing the U substitution with definite integrals in class. I hope that you're working these. I hope that you're watching these videos, that you're making it all the way to the end, that you're practicing these things as you take notes. This is the only way you can learn to do this material, to master the material, is to practice it. So I'll see you in class.